Welcome to Nearpod Lesson 6 on Intro to Moles and Counting Atoms. So, as a general reminder, these are the two things you need to know in this lesson, and then make sure to title your notes this. Okay, so in this unit, we're talking about making medications. So far, we've talked about, okay, what are the basics of a chemical equation or a recipe in chemistry? How do we figure out what products we can make? If we know the type of chemical equation or type of chemical reaction it is, and are following the rule of zero charge. Now we're on to the third thing. How do we calculate how much of something we need for each pill? And and this is especially true if we're trying to make like a pill of aspirin, so on and so forth, right? So because molecules and atoms are so small, if I just take one of this molecule, right, let's say I take a tiny dot, that's one, and I combine it with one molecule of this one, and I make my aspirin, I'm not going to have enough, right? I can not even going to see this molecule of aspirin at all, right? Because atoms and molecules are just way too tiny. So when this says I need one of this thing and one of this thing, it doesn't mean I actually need one of them, right? It actually means I need 1 mole of this amount of stuff. And a mole is kind of like a dozen. So most of you probably know that 1 dozen is 12 things, or one pair of something is 2 things, right? So if I asked you if you have a dozen eggs, how many eggs do you have? Well, if 1 dozen is 12, then I just have 12 eggs, right? Or mathematically speaking, right? What you're doing in your head is taking 1 dozen times 12, because 1 dozen is 12 of anything. So therefore you have 12 eggs, right? And if I said if you have 1 dozen of the C7H3O3 molecule, even though it's a complicated like looking thing, how many of those things do I have? Well, if I have 1 dozen, I'm still going to have 12 of those things, right? It's always true that if I have 1 dozen of something, I will always have 12 of that thing. Math is exactly the same. So 1 dozen of this thing means I have 12 of that thing. Right? So if a dozen is 12 things, a pair is 2 things. How much is a mole? Well, a mole is 602 sectillion of something. So I would definitely write down this information down in red. So 1 mole is 602 sectillion of something. So you can write that in different ways, right? So 1 mole is 602 sectillion spelled out. If I wrote out all of the numbers, it's 602 with 21 zeros at the end. So when you're looking at an equation that says, oh, you need one of these things in green, you don't actually just need one. One of these things means you're using 602 sectillion of that thing. And that would be enough for us to create a product that we can actually see. Right. Another way of writing it is using 6.02 times 10 to the 23rd. So in math class, if you took algebra, this is essentially when you learned scientific notation. And if you haven't learned scientific notation or if you've forgotten it, it's okay. We're going to review here a little bit. So whenever you see a number, decimal, number times 10 to the 23rd, right? Basically, this means 602, and the number exponent on top is the number of times you move the decimal to the right if it's positive and left if it's a negative number, right? So let me share out what I mean by that. So 6.02 times 10 to the 23rd. If I'm going to take this number 23 and move it 23 spaces to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19, 20, 21, 22, 23. So all these blank spaces of spots, each curve represents a 0, right? And that's how I end up back at this number, 602 sectillion, right? You can kind of tell that this way of writing the number is much shorter than this number, right? And that's kind of why we write things in scientific notation when we have numbers that are way too big or way too small. So in the next slide, you'll find a video that kind of gives you a general idea of how big this number 602 sectillion is.